The next dependency of the repository is the local data source used for caching data gotten from the remote API. We're going to implement it now using shared preferences. Hello, welcome to ResoCoder, where you're getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. There are plenty options to choose from when it comes to local data persistence, but as I've said, we are going to implement the local data source using shared preferences. That's because we do not store a lot of data. After all, we are just caching a single NumberTrivia instance. We can take a look at that actually inside the repository. We are just caching one instance. Always whenever we get data from the remote API, we cache it inside the local data source. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and overall go through this lesson at your own pace. We already have the contract for the local data source in place. So let's now set up the test file for creating the implementation of NumberTrivia local data source. Let's go to test, then data sources, and under that, let's create a new file, NumberTrivia local data source test. .dart, of course, and these names are really long, but they are descriptive, which is better than short and non-descriptive names. Now, let's open up another test so that we can just import some things which we need. For example, I've opened the wrong test, but for example, the repository test should contain Mockito and Flutter test. So let's import that so that we have it even inside NumberTrivia local data source test. And as usual, we are just going to start out with setting up the actual test so that we will pass the dependencies, which in this case are shared preferences, into the implementation class, which we have yet to create. So let's create a class which will be for the mocked shared preferences, which are going to be a dependency of the local data source. So mock shared preferences, which will extend mock and implement shared preferences. So let's import shared preferences.dart, which we have already added to our pubspec.yaml file a few parts back. Now, inside the main of the test, inside void main, we of course want to hold the instances of NumberTrivia local data source implementation, which we are about to create. So IMPL for implementation, which will be called simply data source. And then also we want to have an instance of mock shared preferences. Let's just call it mock shared preferences. And now inside the setup, we're going to set it up so that the NumberTrivia local data source implementation will get its dependency passed into the constructor. So let's first construct the mock shared preferences like that. And then let's also construct the non-constructible yet NumberTrivia local data source and pass in the mock shared preferences. With this setup, we now know how the NumberTrivia local data source implementation class should look like, at least what it should take in inside its constructor. So let's jump into NumberTrivia local data source file. And again, we are now going to create a separate implementation file, but we are just going to create an implementation class below the contract, just so that we do not have a bunch of files which are not all that necessary. So let's create a class NumberTrivia local data source implementation, which will implement NumberTrivia local data source contract or abstract class. So now we can also just hit Control Dot in Visual Studio. In IntelliJ, I think it's Alt and Enter, and we're going to create two missing overrides. So now we have not implemented, but at least it's fulfilling the interface. And what we are now going to do is, of course, set up the constructor, which should accept an instance of shared preferences. So let's actually create an instance of it here. So final shared preferences. Let's import shared preferences package. And now we're going to create constructor for final fields. And let's just, for good measure, make this named, optional, but also required. And because we are saying required, we also need to import meta package. So let's import meta.dart. All right. And let's fix all the imports so that they are nicely ordered. And with that, now the test should be not passing, but at least the setup of the test should be good to go, of course, only after I change the parameter to be named. So shared preferences, we can move on to the first actual test. First, we're going to focus on the get last number trivia method, and actually let's move it upwards so that it's first, similar to how it's first inside the contract. Let's just make it also appear first inside the implementation class. All right, so let's focus on this. Calling this getLastNumberTrivia method should return NumberTrivia model. Of course, only given that it has been previously cached. If it was not cached before, so for example, if the user opens the app for the first time, we're going to throw an exception, which we are of course handling inside the repository. As you can see, if you remember from the previous parts, we are handling it right here, cache exception. But the question is, how are we going to store and then later on also retrieve NumberTrivia models inside shared preferences? Well, we cannot just store a class inside shared preferences just like that. We have to first convert it to JSON. And good thing is that we already have a tested implementation of toJSON and from JSON methods on the NumberTrivia model. Because we are using that, we are going to be using it also when we get data from the remote API. We're going to also convert it from JSON. And we are going to do the same thing when we get the data from the shared preferences, where it's also going to be stored as JSON. So now we have to have a way to test with some JSON, because we have to test that calling getLastNumberTrivia will really convert the JSON string present inside shared preferences into our beautiful NumberTrivia models. And you already know from the previous parts what we have to do whenever we test with JSON. We're going to test with fixtures, and we already have some fixtures from the previous parts. If we take a look at the test folder, over in fixtures, we have trivia.double.json and trivia.json. But can we use these fixtures inside the test for NumberTrivia local data source? Because now we are using these fixtures for the test of the model, right? If we take a look at that, we are reading the fixtures here for the model. Well, the thing is, we could use them even for local data source tests, but that's not really a good practice. It's not going to break anything, but still we should strive to keep our tests as close to real data as possible. If we take a look at the model, which is going to be converted to JSON, which is going to be stored inside the preferences, we can see that the toJSON method of the model outputs only two fields, text and number. So this is what's gonna get stored inside the shared preferences. If we take a look at the fixtures which we currently have, they, in addition to text and number fields, they also have the found and type fields. This is going to be returned from the API, but it's not going to be present inside the local cache, in this case shared preferences. Similar thing goes to trivia double, and also of course the double will get converted to an integer before it's stored inside shared preferences because of our logic which we have inside the from JSON method the model will only store integers, not doubles. This is all from the previous part, so if you need a bit of a recap, just go and rewatch those parts regarding the model of the NumberTrivia. Because of this, to really keep it as close to real data as possible, we're going to create another fixture which will be containing only the text and number fields. So let's actually copy this trivia.json fixture and let's create a new file, call it trivia-cached.json, and paste that fixture JSON in here, and we're just going to simply remove the font and type fields. I know it's not all that necessary because of how we've set up the from.json method of the model, but still, just to be safe, you should always keep your data as close to the real one as possible. Now that we have this fixture all set up, we can finally move on to test the getLastNumberTrivia method. So we're going to do test-driven development as always. Let's first create a group inside a test file for the getLastNumberTrivia method. And inside it we're going to have the first test, which will be again arrange, act, and assert kind of a test, saying that getLastNumberTrivia should return NumberTrivia, or we could also say NumberTrivia model, but it doesn't really matter what kind of a thing we say inside the test. From shared preferences, when there is one in the cache. Because of course, when there isn't a cached NumberTrivia inside the cache, we are going to throw an exception, but that will come in the later test. So let's just focus on when everything is nice and dandy and everything is present inside the cache. Under such circumstances, we're going to arrange the mocked shared preferences. So when mocked shared preferences dot get string, because the NumberTrivia models are going to be stored as JSON strings, and now we need to provide a key for the string. And when we are just mocking it, we are going to say that any string. And when a string with any kind of a key is gotten from the mocked shared preferences, we're going to return, not answer, but return, because getString does not return a future, it returns a string directly. And we're going to simply return a fixture. So let's import our fixture reader, beautiful thing, which we have created in the previous parts. And we're going to read a fixture, the cached trivia, so trivia cached.json. Now we can move on to the act phase of the test, in which we are going to store the result of the getLastNumberTrivia call inside a final result. So let's await and call data source.getLastNumberTrivia. And now, what are we going to check for? Well, we first have to verify that we've actually gotten the NumberTrivia, the result, from shared preferences. So we are going to verify that we've called something on the shared preferences. So mocked shared preferences dot get string, and the string which we've called should have a precise key, and we should be getting a string containing the cached NumberTrivia. We're then going to use this key also inside the implementation file. And after we've checked for that, we also expect that the result equals. And what should this result be equal to? Well, it should be equal to the NumberTrivia model converted from the trivia cached JSON fixture. So what are we going to do? Well, of course, we're going to set up a final variable inside the group. We're just going to call it tNumberTrivia model. And it's gonna be equal to NumberTrivia model. Let's import that class over here. And we're just going to say from JSON and read it from the very same fixture which is being returned by the mocked shared preferences. So those things should be equal. And of course, this fixture call returns a string, so we also need to convert it or decode it to a map, because from JSON accepts a map of string dynamic, as you can see. So we're just going to call json.decode this fixture string, and also let's import Dart convert from which the JSON comes. And now we're just going to expect that the result is equal to the NumberTrivia model. So after running this test, it's of course going to completely fail. So let's go ahead and implement it inside the implementation file. We're first going to get the JSON string from the shared preferences. So final JSON string is equal to shared preferences, which is passed into the NumberTrivia local data source implementation class, dot get string, and we should get the same string as we have specified inside the test. So let's just for now copy the key from the test file and paste it into the production file. And now we have the JSON string, and we have to realize that we have really the JSON string and not the future, because getString and all of the other methods of shared preferences are completely synchronous. They do not return futures. But the problem is that our interface of this class expects us to return a future of NumberTrivia model, not a NumberTrivia model itself. This is because probably all of the other local persistence packages work with futures asynchronously, and it's just that shared preferences are probably the only one which works synchronously. So we have kind of future-proofed our interface to work with other packages outside of shared preferences as well. And the way we can convert a value to a future is by returning future.value. It's that simple. And now the value should be the NumberTrivia model converted from this JSON string. So let's just say NumberTrivia model from JSON, and we're going to say JSON.decode, and we're going to decode the JSON string. So let's import Dart convert even to the implementation file. And now let's run the test again. And now it should in fact pass, and it does, which is definitely a good thing. So we've gone from the red phase, where the test does not pass, over to the green phase, which is signified by this green check mark, which means that the test passes. And now we're going to refactor our production code, because I really do not like to pass around some magical strings. Let's just put this cached NumberTrivia string over to a constant. So we are going to extract this string and create a constant above the class. So const cache NumberTrivia is going to be equal to cache NumberTrivia string. And now we're going to use this constant in place of the string literal inside the getString call on the shared preferences object. And in fact, we can also go over to the test file and change this to use also the nice constant instead of the string. And I know that this refactoring was really trivial, but still we have to retest our code just to make sure that it still passes. And it does, of course, but if you are doing some larger refactorings, it may as well not pass. So make sure that always after you refactor something, you rerun all of the tests. Now let's move on to the next test, because of course, we're not just going to always have some instance cached inside the shared preferences. It can also happen that there is nothing inside the shared preferences, in which case we will throw a cache exception. This will usually happen when the user first launches the app, in which case the shared preferences will simply return null when we try to get a string from it. And this could lead to many problems and also possibly an app crash. And you definitely do not want to greet your first time user with an app crashing on him. So definitely this is a really important test which we are about to implement. So let's just copy this previous test and paste it below. Oh, I just see that I have a typo here. It should not be should return NumberTrivia. The should be there only one time, of course. And this next test should throw a cache exception when there is not a cached value. So instead of mocking the shared preferences to return a fixture, we're going to make it return null, because that's what in fact happens whenever you try to get something from shared preferences which is not present there. Now, because we are trying to test for an exception, we are not going to store the result here or do something like that. Now we are trying to test if an exception is thrown from the getLastNumberTrivia method. So we can remove the verify call because we no longer need to verify that since it's already verified above here. We could also leave it in there, but it doesn't really matter. And now we want to expect, not that the result equals some value, but we in fact have to check that this call throws, so throws a is the matcher, throws a, and it should throw a type matcher cache exception. So let's import cache exception over here, and probably also the matcher package. So let's just do that. Above here we're going to import matcher.dart, and this should fix this error. And what are we going to do here? Well, again, we are going to store the method actually inside the reference, inside the variable, which will be called call. So this call is in fact a reference to a function which returns a future NumberTrivia model. And now we're going to expect that calling this method from a higher order function, so call, throws this cache exception. We could of course just also call the getLastNumberTrivia directly from the expect like that, but it becomes quite messy and quite long. So I just like to always create an intermediary variable which holds the method, and that intermediary variable is called call, which we then call from the expect. All right, so let's now run this code. Of course, it's going to completely fail, and let's now go ahead and implement it. So what we want to do here is that we are of course going to check for the null value of this JSON string. So basically, if this JSON string doesn't equal null, we are going to return this future.value and convert the JSON string to NumberTrivia model. Otherwise, we're going to throw a cache exception. So let's just do that. And let's import cache exception, of course. Now let's rerun the test, and this time it should pass. And this is basically it for the getLastNumberTrivia, because it's all that it will do. Return a NumberTrivia model or throw a cache exception, which is then subsequently handled inside the repository, which of course converts it to a cache failure, which is returned not through a special kind of data flow of exceptions, but is returned as a return value of a method. That's what the repository is doing. But because we do not depend on the repository from the data sources, we do not care at all what the repository is doing. And that's the beauty of clean architecture. You can always work on just the piece of code that you are working on currently, and you do not need to worry about all of the other places from which the code will be executed, worry about side effects. No, you just do not care because everything is so nicely separated. Now we're going to move on to the next method, which is cache NumberTrivia. This will be for putting data into preferences. So let's create a test for that. We're going to create a new test group, cache NumberTrivia. The cache NumberTrivia method should call shared preferences to cache the data. So let's create a test, which will be actually an AAA test, should call shared preferences to cache the data. And this is actually really the only thing which we can test for, because we cannot test if the data is actually present inside the preferences, at least not in a unit test. But of course, with the power of mocks, we'll be able to verify if the data passed into the preferences is the correct data, which should be passed over there. And then we have to just rely that the shared preferences package is written correctly and that it will cache the data properly, and then it will be also able to retrieve it properly. But that's outside of our control. What we can only control is if we pass the correct data into the shared preferences, and that's it. So because we really cannot test if the shared preferences contain something, we're just going to remove the arrange part completely, and we're only going to act. And we're going to act by calling data source cache NumberTrivia, and now we have to provide a trivia to cache. And of course, we're going to create a variable final tNumberTrivia model, which will be equal to NumberTrivia model. But this time, it's not going to be from JSON. It's not going to get converted from a fixture, but instead we're just going to create it ourselves. So number will be 1 and text will be test trivia. We could also just create it from a JSON fixture as we are doing in the previous test, but that will not be the case with the actual implementation, because the implementation of cache NumberTrivia will get an already converted instance of the model. So let's just keep it as close to the real code as possible and instantiate it using a constructor and not the from JSON factory. So the trivia to cache is this precise tNumberTrivia model. And now inside the assert part of the test, we will want to verify if the mock shared preferences was called with the proper JSON string. Because after all, setting a string, so calling setString, with the proper key, of course, which is cached NumberTrivia, should happen with the same data as is present inside the NumberTrivia model instance here. So the value of the string being cached inside the shared preferences should be the JSON representation of this tNumberTrivia model, which is being passed in to the cache NumberTrivia call. So let's create a final expected JSON string, which will be equal to JSON again dot encode, because we are trying to encode a map over to a string. So we will just call tNumberTrivia model dot to JSON. And now we're going to verify if the set string contains the expected JSON string inside its call. All right, so let's run the test. And of course, it's going to fail. Now we can, of course, go and implement this test. So inside the implementation, we're going to call shared preferences dot set string, and we're going to set it at the key of cached NumberTrivia. And the value will be, of course, again, JSON.encode trivia to cache, which is the parameter dot to JSON. All right, now let's just somehow keep this nicely formatted. And if we now try to run the test after I format it even more, so let's rerun the test. And it's going to pass. We can cache NumberTrivia successfully, or at least we can call the shared preferences set string successfully. Whether or not it's actually cached somewhere, that's the thing which shared preferences has to take care of. But we also have a warning here, because this method returns future void, but doesn't end with a return statement. Well, we could also change this to void, but just to keep it returning a future, let's just return this shared preferences set string call, which actually returns a future bool. So that's interesting. I didn't even know that. So setting a string returns a future, but getting a string returns not a future. Well, that's definitely interesting. But anyway, if we now even rerun the test after we have added the return statement, so we have to rerun the test, everything still passes, which is definitely a good thing. To go through this tutorial at your own pace once again, and also to get all of the code written in this video, check out the written tutorial from the link in the video description, which is going to take you to resocoder.com. So in this part, we implemented the NumberTrivia local data source doing test-driven development, and now we have only one part of the data layer remaining, which is the remote data source. Of course, we're going to implement it in the next part. And if you don't want to miss that part and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with implementing the local data source and also with test-driven development with the shared preferences package, give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have anything to say, and see you in the next video.